Now in this classroom practice session, this is going to be very useful for doing the certify of as well, all of these. So one law for skin healing is this formula. A equals A sub O Euler's E negative 0.1 T. Now, as we look at this, we want to substitute the values from this question into this formula. So the original wound, that is our A sub O, is 24. Euler's E and it's going to reduce to 14. That'd be our future value. And now what we want to do is solve for T. Well, this is a case where we have to find an exponent. So since this E is an E, we're going to use the natural log. So the first thing we do is get rid of this 24 that's on this side. And this can then be reduced to 7/12. That would be nice. And we're going to take then the natural log of this is equal to, and on the other side now we have E minus 0.1 T. We're going to convert this side to its natural log as well. And the rule when we do that is we take the exponent and put it in front. And keeping in mind that this configuration, natural log base E of E, is just the 1. So this then becomes natural log of 7/12 equals a negative 0.1 T. Again, all this configuration becomes a 1. And then this goes in front, so it's this times 1. We don't need to write the 1. Now to solve it, and this is what you want to try with your calculator, to isolate the T, you're going to divide both sides by a negative 0.1. And then you want to round to 2 decimal places. So take a moment to do that. And you should get something like this. I've left 3 decimal places. I have to round it to 2. So this will then become 5.39. And again, this is in time. Days. All right, let's go on. Now, looking at question 2, it says, how long does it take this amount of principal to double? So we're going to do a little shortcut here. So we don't actually have to use this 3600. We could just say that that is 1, and we want our future amount to double. That's a little shortcut for doing things like this. And then we have Euler's E, and then RT. And we're looking to solve for T. Now we do know some things already. Let's put in there what we can. This side's going to be 2 that we're going to take the natural log of. The E is natural log of E. Let's just do it here. So natural log of E. Now our rate is 6%, and we have the amount of time needed for this to double. Well, we're going to take this, put it in front of the natural log, which in this configuration is 1. So this becomes the natural log of 2 is equal to 0.06 t. And again, we're going to solve this very much like we did the earlier one. Divide both sides by 0.06. And that should give us what t is. All right. Put that in your calculator and check it out. So I have it to 3 decimal places. I need to round it to 2. That will give me 11.55 years. Now in example 3, we see our formula. And some of these are very similar. We're looking for half-life of this substance. So this A is going to be a 1. And this A is going to be half, which is 0.5. Just so you see where it comes from. Now I'm not going to write the 1 here. And we can see it's going to follow a similar protocol of what we've done. We're going to do the natural log of this side, natural log of this side. But when we do that, again, this is going to become 1, but we take this and put it out in front. So we now get the natural log of 0.5 is equal to a negative 0.045 t. So my question is, how do we find out what t is? Well, we're going to divide both sides by a negative 0.045. This all becomes a 1, and we have t equals what? And I get 15.403, rounding it to 2 decimals, 15.40 hours. Again, these first 3 all followed a similar pattern. Now in number 4, again, a similar equation in which we're using Euler's E. We know we have this many, A sub O, 250 bacteria. How many will you have after 13 hours? So it's just a matter of putting this into the calculator. We already know the exponent. So take a moment and see what you come up with. And here we are to round to the nearest whole number. So we see we're going to drop this and make this 7 and 8. And that's our answer. This is number of bacteria. Now in this example, we're going to sell, and we're wondering how many are predicted sales after 17 years. So there's our formula. We know our time is 17 years. So I'm going to change 3 times 17 here. Wanted you to see where it came from. To 51. And now it's just a matter of putting this into your calculator. 1600 plus 510, hit the natural log key, put a parenthesis, 51 plus e. And if you need to put a caret in there, this is e to the first power, and then close the parenthesis and see what you get. And I'm doing these on my calculator as well. So we get 3,631.7. They want us to round to the nearest whole number. So we'll drop this and make this a 2. This is your predicted number of computer sales in 17 years. For example 6 now, we are using the continuous interest formula, and we're just going to substitute. So 6925 Euler's E, and then caret, and then in parentheses 0.065 times 14. And again, you have to put this percentage in correctly, converting it to a decimal. Let's see what you get. So rounding it to 2 decimal places, we see our third decimal place is a 3, so we drop that. And this is our answer in dollars. This is our future amount after 14 years. Now, in this example, this is the most challenging we've had. Read it carefully, and we're going to start off with this formula. So actually, we have to find two things. We have to find K first, this K, and then later we'll find T. Or we know T. We'll have to find something here. You'll see. All right, so let's do some substitution. So the initial population when we studied this was 168,000, and it grows to 199,292. I've got to get that right here. (920), and we have Euler's E here, and we don't know K, but we knew the time is 10. Okay, so how do we solve this? Well, this is using what we've used before. We want to solve for K. So the first thing we're going to do is divide both sides by this. And all of this becomes a 1. And we can just leave it as this. I'm going to use my eraser again, because we did a few of these earlier. Now we're going to take the natural log of this, just leave it like that. You'll put that in your calculator. And then this becomes 10K. And when we took the natural log of this, this all became a 1 here. So this is where we are right now, and I'm going to erase this. So you might say, how do we solve for K? Well, we're going to divide both sides by 10. Now, this is the not tricky but challenging part here. They want you to keep this value for K to, I believe it's 7 decimal places. So let's see what you get for that. So I get K is this, and I'm going to round to 7 decimal places. So I can just erase all of this. So there's my K value. So now the next step is rather easy. You want to find what would be your expected population in the year 2064. So what will your T be once you know this K value? Well, T is going to be 74 years. So we're going to use this same formula, but now for K up here, you have to be very careful putting this in it and then times it by 74, and let's see what you get. Now, when I followed my own directions here, I ended up with this as an answer. And rounding that off to the nearest whole number would just be 633. Now, when I did this before, I just saved this value for K, and I didn't round it to 7 decimal places. So that's why the answer up there is slightly different. Now, I didn't put this into the certify. If I had, they would have counted it wrong. This is the correct answer because we're rounding it, our K value, to 7 places as opposed to saving it. So that's why you need to be careful. And on a test, I would give, of course, partial credit for this. It would just be a rounding error. Okay, let's go on. In example 8, we see we have something we've done already. Let's see if we can set it up and kind of maybe take a shortcut. Okay, so we need to find T. We know what our future amount is going to be. So first step, divide both sides by this. And now this is gone, so I can erase it. And you might say, what do we do next? Well, we're going to take the natural log of this side, the natural log of this side. And remember, this then becomes 1. We take our exponent, put it out in front, and now we have 0.08t equals this. So what do we do now? Well, we're going to divide both sides by 0.08. And you're going to put that into your calculator, and you're going to round to 2 decimals. Let's see what you get. And hopefully you're catching on. Rounding this to 2 decimal places, we just drop the 4. So 8.66 years. All right, just one more to go. So we've done one like this already. There's our basic formula. And our initial amount was 70. The future amount is going to be 36. Euler's E, and then a negative 0.8 t. We need to find out what t is. How long will it take for 70 to become this? Okay, so first thing we're going to do is divide both sides by 70. And this side then becomes a 1, so we can erase that. Now you might simplify this on this side, or you could just leave it like that. You're going to put it in your calculator. What's your next step? Well, you're going to take the natural log of this side, natural log of this side, And remember, this configuration just becomes a 1. We're going to move that out in front, so this becomes a negative 0.8 t. And then we're going to divide both sides by a negative 0.8. And let's see what you get for t. So I get 0.8312. They want us to round to 2 decimal places. So I drop that. And my answer then is 0.83 hours. And that will complete our work.